Good day. So far we've learned a lot about chemical bonding. Now we need to look at how we are going to represent our bonds. The first way that we're going to learn about are Lewis dot diagrams. This is a way to show how the atoms bond to form compounds. So it gives us an idea of what angles the atoms bond at and how they share their electrons. We use dots or crosses to represent the valence electrons of the atoms, dots or crosses. So do you remember what I told you about what valence electrons are? And I told you about the group numbers of the periodic table. I said that the group number 1, group 1 tells you've got 1 valence electron. Group 2 we've got 2 valence electrons. Group 3 we've got 3 valence electrons. And then remember that we said group 4, 4, 5, all the way through to group 8, which has got 8 valence electrons. And what are our valence electrons? Our valence electrons are the number of electrons in our outer energy shell. So if we're looking at drawing the covalent bonding between hydrogen, now remember hydrogen occurs in nature as a diatomic molecule. So what we do is we would draw one hydrogen and we do a little dot. And then we do another hydrogen and then we put a cross. And the reason we're putting a dot and a cross is to show that the one electron is coming from the one hydrogen and the other electron is coming from the other hydrogen. And remember that the hydrogen is in your first energy level where there is only one sp orbital which has got 2 electrons. So that now is full, and that is how the covalent bonding in hydrogen occurs. Let's look at the covalent bonding into fluorine. Fluorine's a little bit different because it's already got 7 valence electrons. So let's see, we would draw our F, and then we go 1, 2, and then we go 3, 4, 5, 6, 7. And then do you see there's a nice big space here? So I could draw another fluorine this side, and I'd be going 1, 2, 3, oops, I should be doing crosses. 1, 2, 3, 4, 5, 6, and then we've got a 7 there. And do you see that there's like a space here? So we could get this little electron is going to go into that space, and that little electron is going to that space. So what we end up with, if I draw it nice and big, is 1, 2, 3, 4, 5, 6, 7, and we've got, there you go, there's your electron from the other fluorine, and we've got our other 6 electrons. So you can see that we've got one shared pair of electrons, that there is a single bond, which is a covalent bonding between the fluorine. So the octet rule, what we've actually done is we've been obeying the octet rule except for the hydrogen. In forming compounds, atoms gain, lose, or share electrons to give a stable electron configuration characterized by 8 valence electrons. Obviously, there are exclusions. The exclusions for this are your hydrogen and your helium, because they only want 2 electrons in their outer energy shell. So if we look at this, we can see that your fluorine, like we just drew here, we have got 1, 2, 3, 4, 5, 6, 7, 8 around that fluorine there. And if we redraw, we can see we've got 8 around that. And it says the octet rule is the most useful in cases involving covalent bonding for carbon, nitrogen, oxygen, and fluorine. So it helps us remember how we are going to have to bond. Everything is trying to get your 8 electrons around it. So let's look at an example of combining carbon and fluorine. So carbon, if we go back, carbon is in group 4, so it's got 4 valence electrons, and fluorine we know is in group 7, so it's got 7 valence electrons. Okay, carbon and fluorine. So if I had to draw this, let's start with our carbon. Here is our carbon, and we've got 4. 1, 2, 3, 4. So do you see that because it's got 4, it needs another 4 to fill it up. So let's start by putting a nice little fluorine over here. So it becomes 1, 2, 3, 4, 5, 6, 7. Then we've got a fluorine that can fit in over here. 1, 2, 3, 4, 5, 6, 7. Then we could put another fluorine in here. 1, 2, 3, 4, 5, 6, 7, and finally we could put a little fluorine in here, which is 1, 2, 3, 4, 5, 6, 7. And the name of this would be carbon tetra because there's 4 of them, fluoride. Carbon tetrafluoride. So that is the name of this compound, which is made up of 1 carbon and 4 fluorines. So you get an idea now that now if we look at the carbon, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8 electrons around the carbon, as well as 8 electrons around each of these fluorines. So every one of these atoms in this molecule is very happy. Let's look at another example. Let's look at carbon dioxide. So again, carbon 4 and oxygen has got 6 valence electrons. 4 and 6. Okay, so carbon dioxide is a little more complicated to draw, and I'll show you why. It's not really, it's just everybody always thinks in straight lines. So here is your carbon. Now if I had to draw my oxygen, let's just draw it up there. We've got 1, 2, 3, 4, 5, 6. So do you see there's a space here and there's a space here? So what we could do is we could fill in the oxygen so it fits in here. Okay, do you understand that? So let me just erase those lines so you can see what I'm doing. We're going to just erase that line there and that line there. We're going to go back to the pen and then I'll show you what happens. So we've got, there is that electron going in there, and here's this electron coming from here. And now we've got our oxygen, and there is going to be 1, 2, 3, 4. So do you see we've actually moved that one to there, that one to there. Now similarly, we could do the oxygen on this side. So we're going to put another little cross here, another little cross here, and that's where our oxygen comes from. And it's 1, 2, 3, 4. So if I had to, if you look at carbon, you'd see that carbon, if you look here, has now got 8 electrons around it. And if I change my color just for fun, you can see that oxygen's got 8 electrons around it. Badly drawn, I admit, but still. And oxygen's got. So if you look at that, you can see that that's where the name comes from, carbon, and then how many oxygens? Carbon dioxide. And what's more important is you can see that actually this is a linear. It's a linear compound. We could draw a line through it. So even though we're at a funny shape, as far as we're concerned, you can see that it's actually a linear compound. Right, so that's the double bond. And these are double bonds. Why are they called double bonds? Because the fact that we've got 1, 2 shared pairs of electrons there, and 1, 2. So that's actually a double bond. And if I had to write that out using Cooper structures, it would, oopsie, let's try again. It would look like that. Okay, but we'll learn about that later. Right, let's look at hydrogen cyanide. Hydrogen cyanide is a triple bond. So hydrogen has got 1 electron, and your cyanide obviously is a little bit more complicated because it's made up of a carbon and a nitrogen. So there is a triple bond between the carbon and the nitrogen. Now because triple bonds are actually 3-dimensional, it is very difficult for us to draw them, so that is why we just draw them as 3 little pairs of electrons, shared pairs of electrons in a row. So that is how a triple bond is drawn. Have a great day.